Hello, today we will be going over another science lesson. This is going to be coming back from where I left off in yesterday's video. So, the first thing we are going to be doing is atoms to atoms, or atoms to grams, and then atoms to atoms. So, this asks how many atoms, or how many grams on 2.0468 atom, or times 10 to the 25th atoms of NaCl. So you saw, like last time, you plug in the number it gives you, and then you put down here. This is Avogadro's number. Avogadro's number, which is 6.022 times 10 to the 23rd power. This is how many atoms are in 1 mole of anything. So you go to moles, and then you eliminate this, so now you're in moles, and you go to grams, and then you just multiply everything on top, divide by everything on the bottom, and you get this number. So, from atoms to moles, and then from moles to grams. And now this shows you how to do grams to atoms. So you do what you did before, you plug in what it gives you, you convert grams to moles, and then you go to moles, to grams, or to atoms, and then you multiply everything on top, divide by everything on the bottom, and you get 1.326 times 10 to the 24th power of atoms. Now remember, because of sig figs, you need 5 sig figs instead of just 4, so that's why there's an extra 0 at the end. Also, make sure you know the ratios, or the ratios. So, mole over moles, grams. You don't need to know, all you need to know is this. But you want, if you need to have, like, the formulas memorized, it's kind of helpful. This is A over 1, A over M, or M over A, and then grams over M. And so now I'm going to give you some time to do this problem on your own. So 10 seconds on now, and I will be back to go over the answer. Okay, so now that I'm back, you're going to see there's some different markings on the paper or on the screen than before. Now, this is because I'm taking the images from my other video and putting them up on the screen. Now, not the one I made yesterday, but I recorded one earlier, or well, yesterday, to post today. But it turns out that for some reason my microphone had been turned off somehow, and so nothing was recorded throughout the entire session of me teaching. But the video did, so I'm just taking screenshots of the video and just pasting them so I can go over it, so I don't have to redraw everything out. So, let's go over this. So, you plug in the number you have, which is 80.223 grams of magnesium. You put the grams down here, and it's over mole, over 1 mole of Mg. 1 mole of Mg is equal to Avogadro's number, and that equals 1.9873 times 10 to the 24th atoms. Now, I forgot to mention this, which I'm happy I'm doing, that I made a video and it didn't work, is that if you ever have how much, or how many moles of X, let's just say X is any element, is in 6.022 atoms, or well, times 10 Avogadro's number. Remember, it's always 1 mole. Now, I'm saying this because, well, because I found a question yesterday. It's like, how many atoms are in 18.02 grams of H2O. Now, 18.02 grams of H2O is 1 mole, and 1 mole is equal to Avogadro's number. So, this is going to be 1 mole. or well 6.022 times 10 to the 23rd power, but you know what I mean. So now we're going to go over how to do atoms to atoms, and after that we're going to go over limiting reactants. Okay, so now I'm back with atoms to atoms, or well, a question based on atoms to atoms. So it asks for the amount or how many atoms of O2 are in, or how many atoms of O2 to atoms of CO2. And so you have this many atoms of O2, and it's asking how many atoms of CO2 is in this many atoms of O2. So now you plug in a number. You go to Avogadro's number to convert to moles. Then you do what we did last video with going from one element to another element. So you come down here, you take the coefficient, you put it on the number of moles of O2. Then you come up here to CO2's coefficient, and you put it in for moles of CO2. You go from moles to moles, then moles to atoms, and then you multiply everything on top and divide everything on the bottom, and you should get 7.686 times 10 to the 23rd power. Now, I think this should have been 7.6857 or 5 something, but it rounds up to 6. So, because there's only 4 numbers here, so it's only 4 sig figs. Now I'm going to give you a few seconds to solve this problem right here, and I will be back to correct it, or well, not correct it, to show you how to do it. Hello, so this should be the answer you got. You should have gotten 1.207 times 10 to the 23rd power atoms of H2O. Now, I screenshotted at the wrong time, and my cursor just ended up being over the 0, because I failed. So, that is a 0, just in case you guys were wondering. So, if you got this wrong, I'm going to go over this. If you don't want to, you can skip to a number I post on the screen right now, so you don't have to do this. So, you plug in this number down here. You go from this number, or you convert this to the Avogadro's number. You take this number and convert it to moles. Now you should put 2 down here for CO or C2H6, because 2 is a coefficient. And then you come up here to 6, and you get 6 moles of H2O. You come down here and you put 1 mole of H2O over, or well, 1 mole of H2O, and then Avogadro's number on top. And you should, after you multiply everything on top and divide by everything on the bottom, you should get 1.207 times 10 to the 23rd power of atoms. Now we're going to go over limiting reactants, and that should be the end of the video. Hello, so now that you know how to do all the other things, we can move on to limiting reactants. Now, to solve a limiting reactant problem, you need a lot of work, as you can see here. So, the first thing you have to look for is the limiting and excess reactants. So how you solve for this is you take the grams that gives you, so you do, it's 3.25 grams of H or NH3 and 3.5 grams of O2. You plug these in, and you find the molar mass, or well, you find the number of moles are in that number. And so what you can do is, since you have the grams of 4 of these, if you divide the mole by 4, you will get the base number that you need. So this is 1 mole of NH3, and this is 1 mole of O2. Now you get these numbers, you divide by the coefficients up here. And so the smaller number is a limiting, and the bigger number is excess. Now, an easier way to think about this is if you have 1 egg and 1 bowl. You have 2 eggs and 1 bowl. You need 1 egg to make a cake, and you need 1 bowl to make a cake. Now you have 0 eggs or 0 bowls and 1 egg, and you have 1 cake. And you have 1 egg left and no bowls remaining. So that is how you can think about this easier. So after you find the limiting, you plug the limiting into into a problem where you find the number of grams are in this, because it asks you how many grams of NO are formed. So you do what you did last video, where you just you go from grams to grams, or from moles to grams, which I didn't really show, but all you do is take out one step. You just go from moles to moles, and then you go from moles to grams, and that's all you do. It's kind of easy. It's easier than, it's one less step, to be honest. And now if you forget, you must remember, if you do it this way with this, you must always remember to make this a 1. If not, if you cannot remember, take the base number you got before, which is this number, and plug it in like normal. So 5 moles of O2 over 4 moles of NO, and you should get the same answer. Now you get the leftover by doing the limiting times the moles of the excess. Now remember, since we're not using the number, this number, you always use 4 moles of this. So as long as you're not doing any equations where you're changing it to other fractions, then you're fine. So you use this number up here to do this, and you get 0.0872 moles of NH3 left over. Now I'm going to show you a problem real quick. I want you to solve it, and I'll go over it. So this is a problem. Solve it like normal, like I showed you before, and I will go over it in a few seconds. Okay, so this is the answer you should have gotten, which is 1.7 or 1.1725 moles of NH3, 0.75 moles of O2 as the limiting, and H or NH3 as the excess. And for the grams of NO, you should have gotten 90.03 grams, and you should have gotten a 3 left over from the excess. Now, you get this by doing what we did before, just changing this to moles and then dividing it by the coefficient. You get this number by doing what we did before, where we plugged in the number we got from up here, multiply across the top, and you end up with this number. Or you could have done it the second way, which is slower but more efficient, so you know you're not getting anything wrong. You use the base number, you just plug it in as you normally would, 5 moles of O2 over, 5 moles of O2, 4 moles of NO, then convert this to moles to grams, and you should get the answer. So, if this was helpful, or if this was helpful, then good. If you missed this, I'd recommend trying to find the grams of H2 or H2O so that you can just get a little bit more practice. And, well, this is going to be the end. I'm not going to cover the H2O because it's just going to take too long, and I don't want to have to rewrite everything. I didn't do it in yesterday's video because I was really tired, and I didn't really want to redraw everything out. So, I'm sorry that I'm not, really going to do everything I can to make sure you guys are right. I was like, if you just watch this over again and just try to figure out how I get everything, because you should understand it from these equations. You should be like, okay, I see what he's doing now. But so, this is the end. If you found this helpful, leave some comments, or leave a comment if you guys like what you want to see, what I could improve on. Leave a like, dislike. I don't really care what you guys do. I just need the criticism and feedback so I know what I can improve on this channel and what I can do to help you guys be better with learning. Now, this learning with Endogen is going to be the end of the stoichiometry for now. Next week, or whenever I do another learning with Endogen, which I'm probably going to try to make one gaming video a week and a learning with Endogen video a week. So, there should be gaming and learning videos every week, and occasionally an animation video when I eventually get around to making them when I have time. So, if you guys enjoyed, if this was helpful, good. If not, I'm sorry. And if you cheat on the test and get 100, give me some credit and have a good day. I'll see you in the next video.